Okay, good day viewers, thanks for watching. Welcome to the Kids channel. Now today's class, I want us to learn density. And you may ask, what is density? But I believe you know what density is before now. I want to give you the concept of density. I'm not your textbook, but I will give you a kind of precise level of understanding that will aid you or make you understand density as a topic. First of all, density is mass of a substance compared to its volume, number one definition. Second, we can define density as mass of a substance per unit volume. Third definition, we can define density as the ratio of mass to its volume. I believe you have your writing materials there because I will not write much on the board. Another thing I want you to know is that density is a scalar quantity. It's a what?
A scalar quantity.
Scalar quantity. And I believe you know what scalar quantity is. The scalar quantity is any quantities that have only magnitude but no direction. While vector are quantities that have both magnitude and direction. Or only for us direction, you're not speaking for it here. Do you understand that?
Yes.
And again, let me give you a secret. Any topic you intend to study in physics, in fact, any topic in physics, provided that the topic has units, endeavor to know the dimension of that topic because you will be asked either in WAEC, West Africa Examination Council, or UTME, that is University Tertiary Examination, University Tertiary Matriculation Examination, or JAM, they are known as JAM now, or any examination, any external exam board, whatever. So now, density is equal to mass over volume. Now let's find the dimension. This is kg, right? And volume is measured in meter cube, right? So this is kilogram per meter cube. How do you find the dimension? M is to minus 2. And someone may ask, what is dimension? I can explain that. Dimension is a way in which physical quantities are related or associated to fundamental quantities. Observe that kg is a unit of a fundamental quantity mass, and meter is a unit of a fundamental quantity length. You just need to know where it is. Now, we've settled that for a fact. Next thing we need to know here is determination of density. How can we determine density? Density can be determined using two methods. One, measurement of regular shape. One, measuring regular shape. Two, measuring irregular shape. Now let's talk about this. Measuring regular shape, how do you do that? We get a mass, an object, and then we weigh it in a chemical balance. Understand now? You measure an object, you want to and then weigh. What about this irregular shape? This one is we measure objects in liquid and weigh. Most especially we use a can known as Pelican can or displacement can. What do I mean? If you have a can like this, then using a wooden side, then we have to place a measuring cylinder beside it. And you know, it has calculations. Okay, so this is water outlet. This one now is a wooden stand. This one is a wooden stand. Wooden stand. Of course, you know this one is a measuring cylinder. Let me extend this line so that I can level this diagram. So this one is the measuring cylinder. This side is the outlet, water outlet. Now, the name of this can is either you call it a Eureka can or displacement can, or call it water displacement can. This is water displacement can. So here we have a string. We have a string here. So this is the irregular solid. Let me this because of space here. So this one now is the string. And this is the solid. Solid object. Solid object. Why? What we have inside here is water. So this is what we use. This is an experiment under measurement of irregular shape. These are the two ways in which you can determine densities of an object. Do you understand now? So next thing I want us to look into is Archimedes' principle. Very simple. Right? Very simple. Archimedes very simple. Another thing is law of rotation, and the third one is after law of rotation, you look at relative density. After relative density, we look at applications of density. After application of density, we look at equilibrium of density, stuff like net center and center of buoyancy. But let's get started here. What is Archimedes' principle? I don't know whether you've observed this. You've observed a lot of water somewhere.
Not deep.
You said what?
Which is I, like after. Yeah. No. Archimedes' principle. Which is I, not deep.
Maybe that depends on.
Okay.
Yeah, so should I guess or British English? So that main Archimedes' principle. Maybe that. So that we're not Englishmen, you get. So, now, what does the principle states? The principle states that when an object is immersed partially or completely in water, it will experience an upthrust. That upthrust now, in brackets, apparent weight loss, which is equal to the fluid displaced. Let me write on the board. This principle states that when a body is immersed partially or completely in water, it experiences an upthrust in brackets apparent weight loss equal to the volume, or should I say equal to the fluid, equal to the weight of the fluid displaced, equal to the weight of the fluid or liquid displaced. Do you understand now? Now, let me give an analogy. Let's take for instance that somewhere around you there is a lot of water, right? And you stood as an observer. You stood, let me say, 4 meters away from the place on that spot when a trailer, this big vehicle, passed through it in motion. You observe that the water will splash on you, but the encounter will not be the same if the vehicle that passed there was a low bus vehicle, not this was vehicle or shuttle bus. So what am I trying to say in essence? The magnitude of the fluid displaced will be equivalent to the weight of the object. Do you get the point now? Now, under law of flotation, the lesser the body, the more it floats on water, right? Good. And if the weight of the body is equivalent to the liquid, the body will be in equilibrium within the liquid. So if a body is lesser compared to the density of the liquid, if completely immersed in water, we experience an upward upthrust. Did you understand that? Good. But when the body is heavier, like the weight of the body is higher compared to the density of the liquid, the body will do what? Sink. Do you understand now? That is the concept of law of rotation. And how do we settle that? And W equal to U means that object is in equilibrium. Now W greater than U, object sinks. W less than U, object floats. This is the concept of flotation. Now let's talk about relative density. Remember I told you I'm not your textbook, but I'm going to help you understand your words. Textbook. Understand this topic. Now let's talk about flotation. Sorry, relative density. What is relative density? Relative density is the ratio of density of an object. Number one definition. Relative density can be defined. If you are watching this video, get your writing material beside you. Relative density can be defined as the ratio of density of objects to the density of water. Number one definition. Number two definition. Relative density can be defined as the ratio of density of an object to the density of water. Mathematically, that is one definition. Mathematically, we have ROD equal to density of object over density of water. Number two definition. Relative density can be defined as the ratio of density of substance to the density of water. Now, mathematically, this is ROD is equal to density of substance over density of water. Do you understand that? I want you to know that relative density has no unit. Relative density has no unit. Do you understand that? So the similarities of this is that relative density has ratio. This one also has ratio. But this one is the ratio of mass to volume. This one is the ratio of density of an object or substance to density of water. Do you understand that? And again, these are scalar. This is a scalar quantity. But the difference is that density has units. Relative density has no units. Did you understand that? Good. Now, I believe that I have done justice to the concept of density. Last but not the least on the board is application of density. Density for application is submarine. It's also for application in ice, that is floating of ice, on water. Do you understand that? Again, it's ship. What is ship cargo? Those that do businessmen that do send their goods from another country from a country to another. Do you understand? So, but what I want us to do very well here is calculation of density. Do you understand? So, I want us to learn calculations of density. So in this video, I'll explain much on density. So I want us to learn calculations in density. So we'll start with simple example. But I think it's better we do that calculation in another class. Let this one be a class for knowledge acquisition. This is theory aspect of density. So follow me to my next class. Thanks for watching.